Hello everyone, this is Proshun sir, the science teacher. I am here to just discuss about the gas laws, and the first gas law, that is the Charles law, which couldn't be done yesterday due to some internet problems. Now starting with the gas law. Now see, gas laws are simply a set of rules or a pack of rules that are written here. The gas laws are certain rules that gases follow when the gases are subjected to a change in pressure, volume, temperature, number of moles of particles, that means constituent molecules or atoms, whatever, and other physical parameters. Boyle's law, Charles law, Gay-Lussac's law, Avogadro's law, and many other laws are there which deal with the gases. For example, Darwin's law of partial pressure is also there. Now, coming to the Charles law, as already stated, that Charles wanted to make some balloons for transportation. That didn't happen actually, but it gives us a good notion regarding the behavior of gases towards the temperature and also towards the volume, because after this only we get the combined gas law. Now whatever, Charles law says that the volume of a given mass of a dry gas, what is dry gas? A gas where there is not a single water molecule present. So volume of a given mass of dry gas increases or decreases by the factor of 1 by 273.15 of its original volume at 0 degree centigrade for each degree centigrade rise or fall in the temperature when pressure or other physical conditions or parameters are kept constant. That means if you just rise the temperature by 1 degree, volume is rose by this, and if you are just decreasing the temperature by 1 degree, the volume falls by this. So this is the factor. Now we can also deal this in the other way. Let V0 equal to volume at 0 degree centigrade, Vt equal to volume at small t degree centigrade. Obviously this may be lesser or better than 0 degree, depending on which we are doing. Now according to Charles law, Vt should be equal to V0 plus, for each degree rise, 270.15 plus V0 by 273.15. This is the condition. This is for 1 degree, but since we are rising it by t degrees, so naturally a factor t will come. So it is V0t. Now you can also take common, that is Vt equal to V0 into 1 plus t by 273.15. This can also be written down as Vt equal to V0 into 273.15 plus t by 273.15. This we can write down very easily. Now a question arises, what is this and how this comes? So it is observed that whenever you take a temperature, this is the factor 1 by this, it is increasing or decreasing. Now on going through these things, a new scale of temperature should or must be framed, where there will be no negative temperature, because this factor is coming as positive obviously when this is rising. So naturally in that new scale we will try to plot like this. Suppose this is your 0 degree centigrade. From here you are getting it. If you extrapolate this like this, you get a temperature that is minus 273.15 degrees centigrade. This is taken as a new scale called 0 Kelvin. This is 273.15 Kelvin. So naturally we can write that T Kelvin equal to T plus 273.15. T degree centigrade equal to this Kelvin. Suppose if this is T Kelvin, you put it here. This is T plus whatever plus this part. So this way we are calculating. It is totally an experimental concept. Now this temperature is also called absolute zero. Why absolute zero? Because it is a hypothetical or imaginary temperature, at which all gases are supposed to occupy the zero volume. So all gases are expected to occupy zero volume. So volume of, or in the other way you can say that all substances are expected to attain the solid state on or before this temperature. To speak the truth, this temperature was not attained totally, although recently we have gone for hydrogen. Things are a bit mesmerizing. I'll come to that in the later video. So this is the case. Now, naturally, you can also, now if you consider the temperature, so if volume increases with temperature like this, so Charles law, if we just go through this into a gross account, we can also say that the volume is directly proportional to the temperature. If you make this thing simple, it means that volume, see, by this, that means temperature increases by 1 degree, volume, this plus this, temperature increases, volume decreases, that means volume increased by temperature. So if you consider that, then you can obviously write V by T, V equal to KT, or V by T equal to K. Here K is called proportionality constant or Charles constant. This is the intrinsic property of the gas which you have taken. The gas will have its own natures. Now, so we can also write in this way. That means for 0 degree and 3 degree, if you compare, V0 by T0 must be equal to Vt by Tt. Now, what is T0? It is 0 Kelvin, as we have taken. It is 0 degree centigrade. So you can write like this: V0 by Vt equal to T0 by Tt. This also can be written down very easily. Now, this can also be applied for many such parameters. And now this can also be applied for another case. I'm just coming to it. Now, if you take this as initial and the final condition, now 0 degree or some degree rise we are taking. Now, if you can take for any temperature. If we take 0 degree instead of 0 degree, you can consider any temperature. Now, suppose if Vi initial volume, Vf final volume, then Ti initial temperature, Tf final temperature. So these are, if you take these conditions, then if you consider the 0 as initial and T as final, obviously it happens also experimentally as observed. So we can write that Vi by Ti gives you Vf by Tf. This can also be written down, this can also be mentioned. And by the way, this is actually the Kelvin scale, the relationship between the centigrade scale and the Kelvin scale. So T degree centigrade is this, as I have already explained. This is the graph of Kelvin scale, or it is the graph of absolute zero. Now the Kelvin scale of temperature or absolute scale of temperature is also known as the thermodynamic scale of temperature. It is also called the thermodynamic scale of temperature. And here we consider this only. So like this we can write. Now again you can also take, now for varying conditions, varying conditions means suppose you are taking one condition here, you change it to some other condition, again you change it to some other condition, then what happens? Then it is observed that V1 by T1 equal to V2 by T2 equal to V3 by T3 equal to equal to Vn by Tn equal to constant K. This is actually again the Charles constant with the proportionality constant as observed. So this is also another relation which we generally get. Now this relation up to this, you can get this as a formula for numerical. Quite naturally you can get. Very less we see that the Charles constant is asked. Now Again, from this, if we try to plot the graph for the Charles law, condition number 1, it is 0 Kelvin, temperature goes here, volume goes here. In such a case, this is an extrapolated line dot dot, from here you get the graph. That means this is actually the dot part. If this is the dot part, no? So if this is 0K, that means from here actually the temperature is measured. That means if you place the origin here, the graph is like this. So this now these graphs are actually called isobars. Why? Because pressure is kept constant in the entire thing. So we call these lines as isobars. This is what V by T equal to constant, or V equal to or V is proportional to T. That is called Charles law. The first graph or the general graph. Now we can also plot a graph for this equation. A graph can also be plotted for this. So let us try to plot a graph for that. I am just plotting here only. Temperature, volume, 0. Suppose this is one. You can also plot a graph like this. Second graph, you can also plot a graph like this. This is P1, P2, P3. That means the graph of volume versus temperature at varying pressures. Here P1, P2, P3. This is the condition actually we have taken. So this is what? Variation of V versus T with respect to varying conditions. So this is the thing that we observe. Now one thing we should keep in mind, whenever we are solving any numerical with respect to the Charles law, you must convert the temperature into Kelvin. In the question they will place the temperature in centigrade, but you should convert the temperature into Kelvin. This is the very important thing, and this is the basis of the Charles law. If you ask for application, it helps us to, first of all, it gave us a new constant for temperature, which is called absolute Kelvin. I'll discuss in this about the absolute Kelvin in some other video. Now, with the help of absolute Kelvin, we can do many things in today's life. Almost all the works have been done in that only. Number one. And number two, by knowing these things, it becomes very easy for us to understand why various gases have differences in the characteristic properties and all. I mean the physical properties. So I hope the Charles law, it is very clear to everybody. So I'm ending my video here. If you like it, then please like, subscribe, and also share my channel, so that any other friends or fellow whatever, if they record this, they can also get it. So I'm ending my video here. Have a nice day.